We are moving on to a factoring unit. So instead of having you multiply to find the answer, we are going to give you the answer and have you find the problem. So we're going to work backwards. So we're going to start off with a little review here of finding the GCF, and GCF stands for greatest common factor of each pair of monomials. So if I were to break 15x to the fourth down, I would have 3 times 5, and then times x to the fourth would be 4 x's. So we have to take that coefficient, that 15, and find the prime factorization of that. So basically we have to break it down so it's all prime numbers. And then 35x squared would be 5 times 7, and 5 and 7 are both prime numbers, and it says x squared. So that's 2 x's. So the greatest common factor would be, what do they have in common? They have a 5 in common, and they have 2 x's in common, so x squared. So the GCF of 15x to the fourth and 35x squared is 5x squared. Okay. This one has a little bit more to it. It has an extra variable. So we're going to do the same thing. 27 would be 3 times 9, and 9 is 3 times 3. So the prime factorization of 27 is 3 times 3 times 3. Then it's y to the third, so we have 3 of those, times z. So there's 1 of those. 45 would be 5 times 9, and 9 is 3 times 3. So 3 times 3 times 5, x squared. So 2 x's times y, so 1y. What do they have in common? They have the 2 3's in common, and they have a y in common. So 3 times 3 is 9, and 1 y in common. So the greatest common factor is 9y. Now, to factor each polynomial, now we have addition or subtraction sign here. So we're going to do the same thing. 8c would be 2 times 4, and 4 is 2 times 2. And c squared is c times c. And 7c would be 7, because 7 is prime, times c. So what do they have in common? They have a c in common. So that is our greatest common factor. That's going to go out front. Then inside of the parentheses right behind it, we have to write what is left over. So looking here, 2 times 2 times 2 is going to be 8, and then we have a c. Plus, what's left at the bottom? We have a 7 left over. So I write that all in one color. C times the quantity of 8c plus 7 is our factored answer here. And if you wanted to check your answer, you could distribute that c, and you should end up back at our original problem. Now we're going to have a trinomial here. So same thing, we're going to have to break everything up. 6n to the 6th power would be 2 times 3 and 6n's. 18n to the 4th power would be 2 times 9, and 9 is 3 times 3, and n to the 4th means 4n's. And then we have a negative 24, so that negative sign is automatically a negative 1. 24 would be 2 times 12. 12 is 2 times 6. 6 is 2 times 3, with one n. Now, what do they have in common? They have a 2, a 3, and one n. So 2 times 3 times n would leave us with 6n. So that is our greatest common factor. And then what do they have left over? This has 5n's, so n to the 5th. This has a 3 and 3 n's, so a positive 3 n to the third. And our last term has a negative 1, 2 2's left. So that would be a negative 4 left over. And that would be our final answer. Now for this, factor each expression. If you look carefully here, you can see that both terms have this m plus 5 in common. So that is their greatest common factor. What is left over? There's a 3m and a plus 4. So that is what gets written in the parentheses as being left over. And that is your final answer. Okay, same situation here, only looks just a tad bit different because there's not a coefficient in that second term there. So b minus 3 is the common factor. What is left over? A 16b here. And then this negative sign. That's really a negative 1. So we can write minus 1. And that is our final answer. Now we're going to move into terms with, polynomials with 4 terms. And we are going to factor by grouping. And what that means is that we're going to look at the first 2 together, and then we're going to look at the second 2 together. So 2x cubed plus 8x. Well, 2 and 8, I can divide, the highest number I can divide out of 2 and 8 is a 2. And x to the third, x to the second, the highest number of x's I could take out of both would be x to the second. And if I divide 2 by 2, I get 1. And x to the third, I took x squared out of that. That would leave me with 1x left over. 8 divided by 2 would be 4 left over. And I took x squared away from x squared, so it would be just x plus 4 left. If you can't look at that problem and do all of that in your head, you are more than welcome to write it all out like I did all the other problems beforehand. I just think that 2 and 8 was kind of an easier problem to factor out of, so I didn't write it all out. Same thing here with 3x and 12. 3 and 12 have a 3 in common, so I'm going to take a 3 out, and it's positive. And 3x has an x, but 12 doesn't have an x, so I can't factor an x out. So what's left over? Well, I took the 3 out, so the x is left, and 12 divided by 3 is 4. Now this one has one more step. If you look, x plus 4 and x plus 4, they both have that, so we're going to factor that out. And then what is left over? 2x squared and a positive 3 is left over, and that is your final answer. And I'm going to do one more here. We're going to factor it since it has 4 terms by grouping. So first 2 and the second 2. This one I'll write out because we have a little bit bigger numbers. So 12 n to the third would be 3 times 4, and 4 is 2 times 2. So if I write them in order, I have that. And then there's 3 n's. Negative 15 automatically has a negative 1, and 15 is 3 times 5, and n squared is 2 n's. So what do they have in common? They have a 3 and 2 n's, so 3n squared out front. What is left over? 2 times 2 and n, so that would be 4n on the top, and negative 1 and 5 at the bottom, so minus 5. And then we're going to look at negative 8n. That would be a negative 1. 8 is 2 times 4, and 4 is 2 times 2 with an n. Positive 10 is 2 times 5. So what do they have in common? They have a 2 in common, so a positive 2. What is left over? Negative 1, 2 times 2, and n. So that would be a negative 4n. And the bottom, out of the 10, there's a 5 left, a positive 5. Now looking at our parentheses, they're opposites. This one over here has a positive 4n when this one over here is negative. And this one over here is a negative 5 when this is a positive 5. So what I'm going to do is factor out a negative 1 out of the last set of parentheses. So if I bring out that negative 1, I'm going to divide everything by negative 1, but when I bring it out, that 2 is going to become a negative 2. So I have to multiply it by that negative 1 that I'm bringing out. And negative 4n divided by a negative 1 would give me a positive 4n. And a positive 5 divided by a negative 5, a positive 5 divided by a negative 1 would leave me with a negative 5. Now, they're all the same in the parentheses. So now that is in common. 4n minus 5, and what is left over? 3n squared minus 2.